welcome to another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 6, Lesson number 5 on percent review. Before we begin, let me remind you that you can find a worksheet that goes along with this video, as well as a homework assignment by clicking on the video's description. Also, don't forget about the QR codes on the top of each worksheet. Use your smartphone or a tablet to scan the code and be brought right to the video associated with the worksheet. Alright, let's begin. Percents are amazingly important in everyday life. In fact, one could actually make the argument that the percent is one of the most common, if not the most common things from mathematics that you actually have to deal with. Whether it's your tax rate, whether it's, like a tip that you have to apply to a meal, whether it's the inflation rate, or anything else, percents are all over the place. Now, a percent always compares two quantities as a proportional relationship out of 100. And very early on, you develop this sense. You talk about giving 100%, or you talk about getting 95% of something done, or you talk about getting an 82% on that spelling test that you took, right? Even when the test only has 25 questions on it, you still understand that that 82% still means something specific, right? It still means that you got the great majority of them right, and very few of them wrong. So what we're going to do today is we're going to work with percents, but this really should be a review, okay? So let's dive right into them. All right. In the first problem, we're dealing with two people, Jonathan and Michaela. Jonathan is getting a raise from $12.50 per hour to $14.75 per hour. His supervisor, Michaela, got a raise from $22 per hour to $25.30 per hour. Okay? Now, letter A is a very easy question. How much, in terms of dollars per hour, is Jonathan's salary going up? That's simple, right? Jonathan's salary is going to go up by this amount, right? We can just do the subtraction. It's simple enough, right? His salary is going up by $2.25 per hour that he works. On the other hand, by what percent is Jonathan's salary increasing? Now, percents always compare two numbers, and the denominator is always sort of the thing you're comparing it to. And what we're comparing in this situation is how much the salary went up to what it started at, not what it ended at. So 225 is to 1250 as x, I'm going to tag a little percent there, is to 100, right? I'm going to stop writing that little percent symbol. I'm going to solve this now using the classic cross multiply. We'll get 1250 times x is equal to 100 times 225, or 2.25 would be 225. We can now divide both sides by 1250, right? Simple manipulation. And what we find is that x is 18. Yeah. So his salary went up by 18%. That's actually quite a healthy raise. Most people are pretty happy if they get a raise of 5%, 6%, 18%, that's a great raise. Now letter C is simple enough as well. Who received the larger increase in salary in terms of dollars per hour? Well, we know that Jonathan had his salary increased by $2.25 an hour. We don't yet know what Michaela's salary went up by, but that's simple. Right? We can just do the subtraction, $25.30 minus $22, and that gives me $3.30. So that's Michaela's, and that's Jonathan's. So clearly, Michaela had the larger increase in terms of just the sheer salary that it went up. The dollars that it went up. She earned $3.30 more per hour. Jonathan earned $2.25 more per hour. But now the question is, who received the larger percent increase? Jonathan got 18%, but what did Michaela get? Pause the video now and see if you can figure out the percent that Michaela's pay went up. All right, well, let's go through it. Hopefully you did essentially what we did in letter B. Again, it's basically the same calculation. We'll say 330 is to what she started with, 22, as x is to 100. In other words, we want to set up always this proportion. Part is to total as percent is to 100. Again, a little cross multiplying, and we'll get 22x is equal to 330. Divide both sides by 22, and x ends up being 15%. Oops, it kind of looks like we lost the 1 there. Let's get that back in. There we go, 15%. So in fact, Jonathan had the larger percent increase, right? He got an 18% increase. Michaela got a 15% increase. Now, it's really up to you to decide who got the better increase in salary. You know, one could definitely make the argument that Michaela got the better end of the deal because she is getting $3.30 more per hour. On the other hand, Jonathan's salary increased by a larger percent. And very often raises are termed in that. Oh, you got a 5% raise. Well, I got a 7% raise. I got the higher raise, right? So, essentially though, this shows us how we set up percents in terms of these proportions out of 100. So we're going to work a couple more kind of common sense real world problems on percents, and then we'll try to find a little bit of a shortcut, okay? So pause the video now and write down what you need to. All right, here we go. Let's take a look at the next problem. Gabe is buying a pair of jeans at a local store priced at $45. All right. He knows the county he lives in has an 8% sales tax added onto the list price. If Gabe has a gift card for $50, will it cover the cost of the jeans and tax? Show work to justify your answer. So this is important, you know, and you could totally see yourself being in this situation, right? You just got through the holidays, you got a gift card from Aunt Marge or whoever, $50, you want to buy those jeans at $45, but you know there's going to be tax. Do you have enough money? All right. Pause the video now if you feel confident enough about your percent work to work through this. All right, let's go through it. Well, what we really need to do is figure out what 8% of $45 is, right? That's my real question. So what will I do? All right, I've got 8 is to 100 as x is to 45, right? The percent is to 100 as the part is to the whole. All right, we can cross multiply now. 100x is equal to 8 times 45, which is 360. Divide both sides by 100, and we find 3.60. So there's your tax, right? Now we haven't answered the question yet. The question was, would that $50 gift card be enough? Well, looks like it, right? With tax, Gabe will have to pay $48.60. So yeah, right? That's less than $50. It's got enough. Okay? Hopefully you got that right. Okay, let me clear out the screen. Pause the video if you need to. Okay, let's do it. Let's do another one that has to do with percent in a real-world application. Very easy to make real-world applications of percent because they happen all the time. Now in exercise 3, we've got actually something that's declining. The population of deer in a forest preserve is predicted to decline by 5% this year. If the current population is 560, what population is predicted for next year? What percent of the deer will remain? So there's 2 questions here. All right. Again, I'd like to ask you to pause the video if you feel confident with percent or confident enough with percent to try to tackle this problem. All right, let's go through it. So again, what we really want to do is we want to initially figure out what 5% of 560 is, right? That's ultimately the question, because once we find that, then we can just subtract that off from the 560 because we're declining. Very important, we're declining. We can subtract that off of 560 to figure out where we'll be next year. All right, so just like in the last problem, what I'm going to do is I'm going to write 5 is to 100, right, as x is to 560. Okay, we can cross multiply. We'll get 100x is equal to 5 times 560. All right, I had to cheat a little bit there, which would be 2800. Okay, then I'll divide both sides by 100, and I'll find out that x is 28. So 28 is 5% of 560. All right, so the deer population next year will be 560 minus 28, which will be 532. Now, the second question is actually very, very important, especially for future lessons. If we go down by 5%, that doesn't look good. Let's try that again. If we go down by 5%, then that means that we have 95% remaining. Now, the reason that that's important is that in future percent work, we're always going to want to think about modeling the percent that remains, not the percent that's been taken away, not the percent that's been added, but the percent that remains. Okay, so it's important when you see that something is decreasing by 5% that you automatically say, that means I have 95% of it remaining. Or if it decreases by 20%, then you have 80% remaining. Okay, so don't brush off that second question. It may seem easy, but it's quite important. All right, pause the video now if you need to. Okay, here we go. So, in exercise 4, we'd like to develop a faster way of working with percents. Almost nobody in the real world sets percents up using ratios. Okay? They use a little trick, if you will. And so common is this trick that it gets built into all of the mathematics that we do from now on. So it's going to be very, very important in the second half of this lesson for you to understand the trick and become fluent with it, if you aren't already. Okay, you might be already using the trick through these problems. I haven't yet. But anyway, let's start with a percent problem that's very common. When you go into a restaurant, you're supposed to leave at least a 15% tip on any meal. All right, so let's say we go order a meal that costs $35 and we want to leave a 15% tip on the meal. Let's figure out what the tip is by just doing a ratio problem, right? That's simple enough, right? We'll do 15 is to 100 as x is to 35. No problem, cross multiply. We have 100x is equal to 15 times 35. That's 525. We'll divide both sides by 100, and we'll find out that the tip is 525. Now, letter B says, find the tip by doing a single multiplication problem, and then it asks, why is this the same as in A? All right. Well, believe it or not, we're going to kind of do the explanation first to figure out how to deal with this. So let's say that we take this thing from 15 divided by 100 is equal to x divided by 35. Well, the thing is, normally we cross multiply here. A fraction equal to a fraction, I cross multiply. That's what I tend to do. But keep in mind that 15 divided by 100 is a number, right? In fact, it's 0.15. So we can solve this problem not by cross multiplying, but by simply multiplying both sides of the equation by 35. In other words, if I want to find 15% of 35, which is what I'm doing here, I can multiply 35 by 0.15. This is often called the decimal form of 15%. So the decimal form of 15% is 0.15. The decimal form of 25% would be 0.25. The decimal form of 36% would be 0.36. And now if I take my calculator out and just do 0.15 times 35, we get that 525, right? In one single multiplication, we get our 525. So this is very important. In fact, we're going to spend the rest of this side of the sheet, or the rest of the lesson, doing this little trick. Pause the video now if you need to. All right, I'm going to scrub out the text. Here it goes. So let's review the trick. All right, finding percents by multiplying. To find p% of a total t, find the product p divided by 100 times t. All right, that's it. Now, most of the time, the p divided by 100 is just expressed as a decimal, right? So if I wanted to find 12%, then 12 divided by 100 is 0.12. It gets a little bit trickier if you have something like 7%, right? Because then you do 7 divided by 100, and you might think it's 0.7, but it's actually 0.07, okay? So we're going to use this a lot, and let's jump into the next exercise and just immediately get practice with it, okay? All right, look at all these problems. Man, there's a ton of them, but they're going to be so fast, right? Watch. It says find each of the following. Write down the product that you use to find your answer. So for instance, 20% of 85. Well, the trick is 20 divided by 100 times 85. But what we really want to do is we want to look at it as 0.20 times 85. All right, and that ends up being 17. 17 is 20% of 85. 12% of 200. Again, I'm going to jump right to this. 0.12 times 200. And that's going to be 24. This gets a little bit harder. And again, if you have any issues, take this, divide by 100 on your calculator. Your calculator will tell you 0.06. After a while, you'll develop that well enough. But we'll do 0.06 times 550, and that's going to be 33. All right? It can get very tricky when you have something like this, 4.5%. It would be so easy to think that that's 0.45, but it's not. In fact, 4.5% is going to be 0.045, right? Times 120, and that gives me a decimal, but I'm okay with that. 5.4. 36% of 96, that's not too bad, right? 0.36 times 96 gives me a messy decimal, 34.56. 2.25%. Oh man, what does that mean? Well, that's 2.25, right? That's 2.25 divided by 100, so that'll be 0.0225. So that is definitely a little bit tricky. 0.0225 times 350. And that just gives me 7.875. All right, so hopefully that makes some sense. Very, very important to have this trick down. All right, so I want you to pause the video, take as much time as you need to, look at these problems, rework through them if you have to, but understand the trick to finding the percent of a total by multiplying by its decimal equivalent. All right, I'm going to clear out the text. Let's do one more problem. All right, just a little multiple choice problem. Which of the following calculations would find 8.5% of 250? Pause the video now, think about what we did in the last problem and how to do this problem. All right, well, the trick is to do 8.5 divided by 100 times 250. If we need to, we could take our calculator out, and what we'd find is that that's 0.085 times 250, and that is choice 4. All right, so that's it. Okay, I'm going to clear this out, and then we're going to finish up the lesson. All right, let's finish. So today, we did some very basic review on what percents are, i.e. proportions out of 100, how to figure them out using proportional reasoning, but also how to find percents of totals by multiplying by their decimal equivalent, something that will be very important in the coming lessons. For now, I'd like to thank you for joining me for another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.